don't know, y'all. Technology is a something, isn't it? Well, this is the second time I'm gonna try and make this video here to explain some stuff here. Let me make sure that I'm on the right one here. Okay. Actually, I need to do this one right here. Nope, that's not the right one. Is it this one? This one. Okay. All right. Welcome back for those that were watching for the last hour. Welcome. Like, comment, share, subscribe. Go over to the Code Black Slack community over here, and you can talk about me that I'm gonna have to redo this video for the second time. But I'm all about it. I'm all about teaching. So here we go. We were talking about the 4 pillars of object-oriented programming. This will not be an hour-long video because I've got all the code done already. And I'm going to use this Keylime interactive site here to kind of explain. Before we get into it, we're going to talk about four things that have to do with some terminology. We're going to talk about objects, classes, method, and instance. Okay, an instance is just they're like objects. They are instances of an object, basically. Okay, like it says there. A blueprint for a car design is a class description. All the cars manufactured from that blueprint are objects of that class. Your car that has been made from that blueprint is an instance of that class. So we have methods, which can modify a class state that would apply across all the instances of the class. We have the class, which is the model or standard about what the capability of what an object can do. And an object is the instance of a class. It's the working entity of a class. So let me go back to my logic here that I came up with here. I've gone ahead and so I'm going to open up a project that I've already spent the last hour doing. And I'll go over to my repo here. It's not there. It's actually here. See. Source. Maybe I should just pin that to quick access. There we go. So we're gonna be using it. So I'm just going here. And our live session. And this is our class library and a solution that uses our class library. So let's go back to the class library that I created, and I'll try to explain all of this here again. I'm just chuckling myself. All right, so let's start, and I said we're going to go over the 4 pillars of object-oriented programming. For those of you all who are in the Code Black Learning, Capstone Learning, this is on page 155 of the CompTIA book, kind of, sort of. So let me kind of explain it using the CompTIA book here and the site that I'm linked up to here. The CompTIA book says that object-oriented programming is a popular way of designing code. The idea is that creating recognizable things within the code and making them interact through defined methods makes the code easier to maintain and update. I know about that. I've seen some complex code out there. An object can have inner workings that other parts of the program cannot affect, and outer or public values and things that the object can do that other parts of the program can read or ask the object to change or do. That is a mouthful. Objects can have attributes, properties, and methods. What is an attribute? An attribute is a value or a data type that's stored that defines the object. They're stored within the object as fields or private variables. Other programs cannot access or change the fields directly. They have to call a particular method to do that. A method defines what you can do to an object. So for example, a customer object might have a change address method. When another part of the program calls it change address method, it also passes a string with a well-formed address to the object because that is what the method expects. And then you have properties. It represents an alternative way of accessing a field publicly. So let's go back to here and talk about the 4 principles. These 4 principles are the pillars of object-oriented programming. You'll want to understand, at least at a very high level, what these 4 do and what they are, okay? If you understand these 4 pillars, it makes object-oriented programming much, much easier to grasp, okay? The best way to look at this is to think of the, you know what, let me do one other thing too. Copy that video URL, blah, blah, blah. The best way to look at that is to think of the, here it is again. There we go. Let's do this here. There we go. I have to put that out there. Okay. It's easier to remember something for some if you use a common little saying or phrase or acronym or whatever. This one is APIE, APIE, APIE. Abstraction, encapsulation, polymorphism, abstraction, inheritance, abstraction, polymorphism, inheritance, and encapsulation. It's 10:30 at night, yo. If you remember those 4, you'll get the 4 pillars. What they do, on the other hand, takes a little bit of work. So let's start with the A. Abstraction and encapsulation go hand in hand to one another. It's like cooking sweet potato pie with nutmeg and vanilla, right? You can't have one without the other, at least for a good pie. So what is encapsulation? Encapsulation is the process of locking down your code and maintaining it privately within itself. What do I mean by that? If you have a class that contains a bunch of different attributes in it, you can lock down each of those attributes inside of that class one by one, or you can lock down the entire class too. Here's a great example of that, and I did this in the previous video. I'm doing this again. Okay. So what we've done is we've come up with a class library called School District. Our School District library consists of the following. It consists of students, teachers, the type of school, the actual school, and school district. Okay. The teachers have an ID, a name, an address, a phone number, and a grade that they teach. Students also have an ID, name, address, phone, parents, and their gender. The school type, we have a little key here. We have if it's a Head Start or early educational school. We have if it's a high school. Why is that not working? I'll tell you. My Zoom's not working here. I'll tell you. It's like my mouse wheel doesn't want to work. There we go. Oh, now it works. Okay, so our school type has our grade level indicator. and it has an alternative school, if it's an alternative school or not. And up here we have a key for our grade level indicator. If it's an elementary school, we have our number 2, which would signify it's an elementary school. We have our junior high school, which is a 3, 4 for high school, and 1 for a Head Start or early education. Here we have our actual school. Now, our school is the first indicator of another pillar of object-oriented programming we're going to talk about in a minute, and that's inheritance. But if you notice, all of these types here, all of these properties that I've listed so far, they all have public next to them, because I want to expose all of these properties and these 2 methods that I created to my program over here, which is my console application. I want to have access to all of it. Now, let's say I didn't. Let's say I want to restrict the name of a student or all the students' names, and I only care about their IDs, okay? Because I don't want that information out there. How would you do that? Well, encapsulation allows you to do that. What encapsulation is the ability or the act of locking down your information and not exposing it to outside classes that don't have access to this class. Or if they do have access to this class, you want to lock it down because that information you don't want to share with people. How do you do that? Well, I can change this from public to internal. Now, in doing so, I'm going to get an error over here in a second here. In my other one here. So if I save this and I go into my program, I'm going to have an error. Save that. Show. Because I have a student name over here somewhere. And actually, that's not going to blow up for me because everything that's in this particular namespace, I rebuilt this. I thought I should get an error there. Oh, I guess not. Now, if I try to, now that means what I basically did was, since this object here, this student object here, and this student method here is not using the name, or it's using the name here, but what's going to happen is if I try to create a new instance of this student object here, which I did here, and that's not used. Is that used? It is used. If I come over here and I try to use in school dot actually not school, it's student, in student, you'll see that I have gender, parent, student address, student ID, and phone. I don't have student name anywhere. Why don't I have student name? Because of encapsulation. I have locked down the ability for any outside any object instantiated or created from this class, this student class, from being able to access the student name. So what this is actually 2 pillars of object-oriented programming working together. This is abstraction and encapsulation at the same time, right? I'm only showing the pertinent details that I want to this program here. Okay? That's all I'm doing. Now, what I can do is, based on this right here, which has access to this particular student class, because it's right here. And internal, what that is, internal means that anything which is inside of this namespace here should have access to see this string. If it's outside of that namespace, however, like this right here, I don't have access to it. So what's going to happen is if I change this to private, now I'm going to start getting some errors here, because since it's private, this class up here, the school class, and this student object that's in the school class can't see this anymore. It's no longer available. If I hover over it, it says I can't see this because of its protection level. If I click on this, it should take me to MSDN or Microsoft here in a minute. And it says a member is inaccessible due to its protection level. And here's an example here. See how my method is a private and I can't do that because I'm going to get an error there? Okay. So I can say internal here. Why would I use internal? Let's say I still want to, behind the scenes, know that student's name because of a database or something like that. Or let's say I have a lookup that goes and looks up this information and returns it to me, and it allows me to parse through this, and student name is one of those pieces of information. But I don't want my program over here that's going to spit out information to the user to have them identify the name of the student. That protects them. Okay, it protects your data, and it protects your student, and it locks down your application. So doing this right here is what is called encapsulation. Abstraction is the act of showing only the stuff that I need. Okay, so let me change this back to public, and we're good there. So that's two of the pillars covered right away. Excuse me. Make sure I'm still broadcasting myself here. Okay, and make sure I'm still live streaming. I don't know why it says that. Okay. Now, what's the next one? The next pillar that I'm going to talk about, and I kind of skipped over the P for polymorphism. That's because abstraction and encapsulation go hand in hand. Let's go back to the P for polymorphism. What is polymorphism? So if you break that word down into its parts, poly means many, morph means form, and ism means taking on, basically. So polymorphism is the act of taking on multiple forms of something. Polymorphic. Okay. What does that mean? You can create a method or an object to have multiple forms and do the same thing, basically. Let's go back to our school district class here. And here we have two add student methods. And all a method is just you're going to take a block of code and put it in somewhere. You're going to just, that one block of code that one method handles that one block of code. If you call that method, you're going to do whatever you put in there each time. Okay. Now, how does that change? Well, you see I have two add student methods here and here. What changes that? Well, the form of this add student method is different from the form of this add student method. This is what we call overloading. Okay. If I go back over to here, here's an example of that polymorphism in action. So I've created a default student object, and it's returning a student. And then I also have a given student one that I can actually type information into and add a student that way. What makes this polymorphic is if you hover over the add student, you can see where I have one overload. And if I click on this, oh, not there, let me go back. If I hover over this, let me just actually type this up so you can see it in action here. In school, add student. And you can see here in my window here, it says there's one of two. So what this is polymorphism in action. I'm using the exact same method, but I'm using two different forms of the exact same method, which gives me the ability to make my code more familiar. And then one of the other things I can do over here is I can say adds a student by name, address, phone, parent, and gender. Return student. If I come down here, I'll add one here. Add a default. Used to re a form. Return student. Save that, and I can go over here and I'll just type this in again. Actually, I should just be able to hover over it and see it gives me what that does in there. Each of them says this one adds a student by name, address, phone number, parents, gender, and then this one returns a student here and tells you what it does here. So that's polymorphism, changing the form of something and giving it multiple forms. The last one is inheritance. And let me go back to this school district class here. So this student class here and this teacher class here and the school type class here are what we call base classes, parent classes. Okay. Now, your school class is inheriting properties from the school type, the student, and the teacher class, and actually it's also inheriting from the system.collections.generic.list class on both of these, because I'm getting a list of students and a list of teachers. Okay. This school district class inherits from all of them, because school inherits from school district. School district inherits from school. School inherits from school type, student, and teacher. And there we go. Okay. So inheritance is the ability to allow child object and classes to utilize the variables, the objects, the properties, the methods, the functions of a parent class. Okay, that's what inheritance basically is in a nutshell. So let's run Okay, since I'm pardon me. Whew. Since I'm using a collection of students, what I'm doing here on this line right here is I'm creating a container which will hold nothing but students in it. It's a collection of students, like a file cabinet, kind of, sort of, right? That's what I'm doing here. Now, the next thing I do is when you use a collection of students or a collection of objects, you have to add objects to that collection. So basically what I'm doing here, and I could do it this way. Let's do it this way. Instead of doing it that way. And I can say students.add. This way. There we go. Okay. So what I'm doing here is I'm using this method over here that gives me the generic student right here. I'm going to add one there. And then I have, this is a new default student. And this is add a new given student. Okay, get rid of this line here because I don't need it anymore. So now, all I'm doing here is I'm just adding students into my Tupperware container of students. Right? This is my Tupperware container of students here. And I'm just putting students into my Tupperware container of students here. Okay. Now, the next thing I do is I'm going to create my school, which I've got going on here. And then I just populate the school information in there. Here's a list of students. And here's our list of students up here that we created. And then we have our teachers as well. And we can add our teachers this way, like we did here. And then finally, what I do is I add, because I have to instantiate a new list of objects to populate that with my schools with. And then once I do that, then I just add my new and actually I can do it. I think I can do it this way. See if I can do it this way. Can I do it that way? And I think I could. Just leave that alone now. Let's keep it simple. I'm trying to do too much. Okay, so so basically what I'm doing here I thought I could do that. There we go. There we go. So all I'm doing is I'm adding my schools, my school here to this schools. And I can just loop through and do this over and over again if I wanted to. But in this instance, I'm just doing it one time. All right, so then down here, I'm creating an output to display to the user. Let's go ahead and run this. And here we go. Yet again, one teacher, two students, and so on and so forth. Let's say I want to get information on those students. Then what I would need to do is I need to create another loop like I did here and loop that under here, or I'd probably put it underneath here and then loop through it and display all my teacher names and so on and so forth. So, but anyway, that's the 4 pillars of object-oriented programming. I've made changes to this, so now, like I do with all of my code, I'm going to go ahead and put this over in the Code Black repository. That repository is private. If you want access to that repository, you need to subscribe and shoot me a message, and I will grant you access to that repository if you don't already have access to that repository. So how do we do that? Go into our Git. I'm where I need to be. Git add star. Should have a few changes here. You know what? Git status. Those are the stuff I've changed. Git commit m. Actually, make sure I'm blah blah blah. Added changes to OP basics. Solution after I discovered say git push, and that's just going to push up my changes to the repo. If I go over to my GitHub account, I don't think I'm signed in still. I shouldn't be signed in yet. Let me hide this because y'all don't need to know that. There we go. A 2-factor. There we go. Go over to my repo. Here's Code Black Learning. And you'll see that I've got one branch in there, and here's my code here. These are the changes that I've made. Should do a little cleaning up. You see this is old over here. This is the new stuff that I did here. Yeah. And so, yeah. So there we go. Like I said, if you want access to this repo, you gotta subscribe. And you have to join the Slack community over here, Code Black or the Capstone community. Capstone's by invite only. Code Black, you got to be a member of Code Black to do it. So until next time, like I said, be blessed. You can do this. I have all the faith in you, and all of the confidence is yours. If you have questions, reach out to me on the chat or on my YouTube channel. Again, I don't know everything. I've been doing this for a little while, 21 years, but I'm not the end all be all. In fact, I struggle too with some of this too at times, but I know who to talk to and who can help me. So until next time, peace, be blessed, and God bless.